All right, now today we're going to look at solving absolute value equations and inequalities. So we have three different kinds. Again, here we have ones with the equal sign, absolute value with the equal sign. We have absolute value with the less than sign, and then we'll see an absolute value with the greater than sign. So we'll start with the absolute value with the equal sign. And if you think about absolute value means the distance from zero. So it can be the positive distance or the negative distance. That doesn't matter. So for us to be able to solve absolute value equations, we're going to want to split these into two problems. One that says the stuff inside the absolute value is either equal to 11 or the stuff inside the absolute value is equal to negative 11, because that's the only way we can get 11 as an answer. If you think back when we were working with absolute values in younger years, absolute value of 11 is equal to 11. The absolute value of negative 11 is equal to 11. And that's the only way you can get 11 as the answer to an absolute value problem. So it has to be either, the stuff in here has to either be 11 or negative 11. And then we solve that. So subtract 3 on both sides. 11 take away 3 is 8. Divide by 2. X's could be 4. Or same steps over here. We're not going to get quite the same numbers though. Negative 11 take away 3 is negative 14, which means when we divide by 2, we're getting negative 7. So either X is 4, because 4 times 2 is 8, plus 3 is 11, or negative 7, because 2 times negative 7 is negative 14, plus 3 is negative 11, which would simplify to 11 once we do the absolute value. Okay, so we have two answers. One the positive and one with the negative. Okay, we do have to have the absolute value part of the problem by itself on one side of the equal sign before you split it though. All right, the next problem is a less than problem. And if you think about the fact that we want the absolute value to be less than 2, if you're looking at a number line, we want it to be less than 2 spaces from 0. So we could be from here to here. This is where we want our answers to be. We have to figure out what x's would make it be in there. We split these also. So we will split this to x minus 3 is less than 2, just like we see there. And we will split it to x minus 3 is greater than negative 2. Kind of squeezing into that there. So x minus 3 is less than 2, and x minus 3 is greater than negative 2, because we want it to be larger than negative 2 and less than the 2. We want it in between here. And then we solve these. So if I add 3, x is less than 5, and if I add 3 here, x is greater than 1. Now, when I graph these, remember this is an and statement. Less than will produce an and statement. So when I graph these, I want where the shading is for both. So x greater than, less than 5, here's open circle going this way. X greater than 1, here's 1, open circle going this way. Where they have the double shading is in between here. So from 1 to 5 is where our final answer is. Okay, between 1 and 5. The last one is a greater than problem. If you think about this, when we are talking about greater than 2, we want our answer to be greater than 2 spaces away from 0. So it has to be beyond 2 or beyond negative 2 on the number line. We're going to split this the same way, but when we split it, we don't have an and statement this time, we have an or statement. So greater than produces an or statement. So x minus 3 is greater than 2, or x minus 3 is less than negative 2. It's still the same split. We keep exactly what we have here, and then we flip the inequality sign and give the opposite number, make it negative, and then we solve them. So add 3, x is greater than 5, add 3, x is less than 1. Now, because this is an or statement, when we have greater than, we want everything. So x is greater than 5. Here's the 5. X is less than 1. We want anywhere that there's shading in our answer. So we want all of this and all of this to be in our solution. Okay, so our final answer has shading at both ends of it when we have a greater than problem.